This video is helping you, or will help you fill out the back page, or the back flap of your Unit 2 Polynomials flipbook. So take your flipbook, turn it upside down, and you will see some additional information on the back of that flipbook that I want to cover with you. It's extra information that I know down the road will be helpful to you, so we're going to go over this together and hopefully be able to remember this as we go through the rest of Integrated Math 2. You should see this, these words on your page, degree of a monomial. And what we're defining is, we're defining this thing called degree. And degree is actually giving you information on the exponents that are in a monomial, or something about the exponents. This degree will be helpful later on. You'll probably see it more in Integrated Math 3. It's going to give you an idea basically what the graph of a particular expression or equation is going to look like based on the degree. So let's define this. The degree of a monomial is defined as, degree of a monomial is the sum of the exponents of all of the variables. The sum of the exponents of all of the variables. So let's take a look at some example monomials and see how this works. Let's say that your monomial is 4. It's just the number 4. Remember, a monomial doesn't have to have a variable. It can just be a constant number. The degree of this monomial is 0. I'm not sure why I'm getting that very strange thing. Let's take a look here. Oh, I know why. Let's try it again. The degree is 0. Notice there are no exponents here. Well, technically, I guess if we're going to be technical, there is an exponent here. This is 4 to the first power. Anything to the first power just gives you that base number back again. But there's no variables here. Because there's no variables, we can't count that as an exponent. Notice it's the sum of the exponents of all the variables. There are no variables, the degree is 0. How about 7x? The monomial is 7x. Well, this x does have an exponent. We don't have to write it, but this is the same as x to the first power. Because that's the only exponent in this monomial, this degree is 1. It's just 1. Let's take a look at the next one. 2 times x squared. That's a monomial. It's terms that are multiplied, values that are multiplied together. That's one term. The exponent here is 2. The only exponent we have on a variable is 2. The degree is 2. Now in this case we have two variables, 3m squared p. 3 times m squared times p. Well, this p does have an exponent. It's a 1. We don't have to write it, but we can assume that it's there. We have two exponents now, a squared exponent and a single, or an exponent of 1. So it says it's the sum of the exponents. So 2 plus 1 is 3. So I'll put 2 plus 1. Hold on as my computer catches up for a moment. 2 plus 1 is equal to 3. And let's take a look at the last one, the crazy one. Negative 6 times x cubed times y squared times z to the first power. We have 3 variables with 3 exponents. We've got 3 plus 2 plus 1. So the degree of this monomial is 6. The degree is 6. That kind of looks confusing here. Let's fix that equal sign. The degree of this monomial is 6. All right. Let's take a look at the degrees of polynomials. A little bit different. Degree of a polynomial. The degree of a polynomial is the largest exponent of the variable, the largest exponent. So when we start getting these expressions with more than one term, now we're no longer going to be adding up all of the exponents in one of the terms. All we're doing is looking at all the terms and finding the largest exponent. So let's take a look at the first one. 2x minus 9 is a binomial. We're looking at the largest exponent of the variable. Well, x has an exponent of 1. We don't look at 9 because 9 is not a variable. So this is a degree of 1, or a first degree polynomial. And if you graph that, you will end up with a line. So this is called a linear expression. Or it could be a linear equation if this was y equals 2x minus 9. Take a look at the next one. 3g squared plus 2g minus 4. We've got an exponent of 2 here, an exponent of 1 here, and there's no variable on the last term. Well, the largest exponent on a variable is 2. This is a degree of 2. And we call this a quadratic. You'll be seeing a lot of these in integrated math too. This is a quadratic. In this case, it's a quadratic expression. We'll be dealing with a lot of quadratic equations. All right, next one. Negative 6t cubed plus 3t squared plus 1. Notice that the largest exponent, actually, let's go ahead and mark these so we see them. Largest exponent is 1, largest exponent is 2, largest exponent of a variable is 3, and that means the degree of this polynomial is 3. And a polynomial with a degree of 3 is called a cubic expression, or cubic polynomial. Last one, 4 times k, that has an exponent of 1, plus 3k to the 4th minus 12. We'll circle this one. The largest exponent is 4. That means our degree is 4. This is a 4th degree polynomial, and that is called a quartic. You kind of think about where these names come from. Cube, cubic. A cube is 3-dimensional, so it has it's 3rd degree. And QUAR, you think of quarter, which is 1/4 of a dollar. A quart is 1/4 of a gallon. So QUAR usually represents the number 4, and that's where we're getting that quartic. Now, the confusing part for me is quadratic starts with QUAD as well, and yet that is a degree of 2. That's a discussion for another time. But these are your names of the different degrees of polynomials.